Every now and then something comes along that feels like a real step change in AI. And I think DeepSeek may have just dropped one of the biggest upgrades we've seen to how AI models are actually built. It's a fundamental shift in how they think, and we're about to break down exactly how it works. To really understand why this is such a game changer, we have to start with a pretty simple question. What is the single biggest, most inefficient waste of an AI's time and energy right now? And the answer is right here. It's constantly having to relearn and recompute the exact same simple common patterns again and again and again. It is an inefficiency that's baked right into the core of today's models, and honestly, it's a huge, huge problem. See, for years, the main strategy to make AI smarter was, well, kind of simple. Just make it bigger. More parameters, more data, bigger brain. But we hit a wall. These models got so ridiculously massive that running them was just absurdly expensive. And this led to a kind of cheat code called Mixture of Experts, or MO. So you can think of it like this. The old way was like using your entire brain for every single thought. Super powerful, sure, but totally exhausting. The MOE cheat code is way smarter. It says, hey, for any given task, let's only fire up a few specialized parts of the brain. This let models get huge without needing a supercomputer's worth of power every single second. And for a while, everybody thought this was the future of AI. But here's the catch. DeepSeek realized that even this really clever MOE approach didn't fix a much deeper, more fundamental flaw. It's a problem that isn't about size or specialization. It's about memory. A very specific kind of memory that you and I just take for granted. Just think about it for a second. When you see the phrase Alexander the Great, your brain doesn't have to painstakingly piece together who he was from first principles. You just know. It's an instant lookup. An AI, on the other hand, even after seeing that name millions of times, still spends a surprising amount of its brain power rebuilding that concept from scratch. Every single time. I mean, can you imagine having to explain who Taylor Swift is from the ground up every time someone says her name? It would be incredibly inefficient, right? Well, that's what our most advanced AIs are doing constantly with common names, phrases, and ideas. And this is where DeepSeek's brilliant solution comes into play. It's called ENGRAM. And the core idea is just elegantly simple. What if we just gave the AI a dedicated, super fast memory for all these common things? A shortcut, basically, so the main brain can stop wasting time on the easy stuff and focus on actual hard thinking. So, to put it simply, an engram is like a memory warehouse. It stores common word patterns, things like United States or Princess of Wales, so the model can just instantly pull up their meaning, instead of having to recompute it through dozens of complex math layers. And the way it works is really clever. 4 simple steps. First, the model sees a common phrase. Second, it does a lightning-fast lookup in that memory warehouse. But, and this is the truly brilliant part in step 3, it doesn't just blindly trust what it finds. A special truth detector gate checks if that memory actually makes sense in the current context. And finally, if it's a match, that memory gets injected right into the model's thinking process. It's a fantastic little check and balance system. This whole approach led DeepSeek to a critical discovery about the architecture itself. It's all about balance. You can't just have all thinking experts or all memory. You need a sweet spot. And they found that dedicating about a quarter of the model's total power to this engram memory gives you the perfect mix. It stops the model from wasting time on simple stuff without losing its ability to do deep thinking. Okay, so the theory sounds fantastic, right? But does it actually work in the real world? Well, DeepSeek put ENGRAM to the test. They built several huge models to see how a memory-enhanced AI really stacks up against a traditional one. And this table shows you exactly how they did it. Just look at that ENGRAM 27B model. They started with a standard model that had 72 thinking experts, and as you can see in that last column, 0 memory. Then they cut the number of experts down to 55 and reallocated all that extra capacity, creating a massive 5.7 billion parameter memory module. So they're not just making the brain think harder, they're giving it a much, much bigger library to draw from. And wow, the results are immediate. On a huge benchmark called the pile, which basically measures how well a model can predict the next word, the standard model gets a loss score of 2.091. The ENGRAM model, using the same amount of compute, drops that score all the way down to 1.960. Remember, lower is better here, so this shows the ENGRAM model is just fundamentally better at understanding and predicting language. But here's the part that I think even surprised the researchers. You'd totally expect a memory module to help with remembering facts, right?
But ENGRAM also gives a major boost to tasks that feel like pure thinking. Scores on coding tests and math reasoning problems both climbed way up. So the big question is, why would better memory lead to better reasoning?
The answer to that question is what reveals why this technology could honestly change everything. It leads to deeper thinking, a mastery of long documents, and it does all of this with incredible efficiency.
So here's the secret. DeepSeek's analysis figured out the why. In a normal model, the first few layers are basically wasted just reconstructing basic concepts from scratch. ENGRAM handles all that low-level work instantly. This means the model gets to a deep, useful understanding way earlier. What the old model figures out at layer 12, the ENGRAM model gets at layer 5. It effectively makes the model deeper and smarter without adding a single extra layer. And that is the key to better reasoning. By skipping all the remedial work, the model has way more brain power left for genuine problem solving.
Now, this effect goes into total overdrive when you start dealing with really long documents. Because ENGRAM is handling all the small local stuff, the model's main attention can just focus on the big picture, the global context. And the results are just staggering. On the needle in a haystack test, the score leaps from 84.2 all the way up to 97. And for tracking information in a long text, a jump from 77 to 89. I mean, those aren't small gains. That's a massive improvement.
Okay, I know what you're thinking. This all sounds amazing in a research paper, but what about the real world? What's the catch? Can you actually run a system with a gigantic memory module without grinding everything to a halt? Well, the answer is a huge, resounding yes. DeepSeek engineered the system so it can pre-fetch memory from standard, way cheaper CPU RAM before it's even needed. And their tests show that even when you bolt on a colossal 100 billion parameter memory module, the maximum slowdown was a tiny 2.8%. That's it. This isn't just a lab experiment, this is absolutely production ready. So if there's one thing to take away from all this, it's this. ENGRAM isn't just about giving AI a better memory for trivia. By offloading all the simple, repetitive work, it frees up the core AI to think faster, deeper, and way more efficiently on the problems that actually matter. And that really leaves us with a final, fascinating question to chew on. For years, AI development has been held back by this fundamental inefficiency. Now that it might be solved, if an AI no longer has to waste its energy on the simple stuff, what new, truly complex problems could it